Yeah, I'm recording already, Nathan.
Okay. So, good morning, everyone. Thank you for being here. Today, I'm going to be presenting about hotspot analysis in ArcGIS. Let me share my screen. So, for those that are not very used to spatial analysis, this is ArcGIS. And it's going to be like a brief introduction. It's going to be very simple, very easy, but also it's going to be strictly to the point, so directly to the point. So we're just gonna see how to get the information here, the data inside the ArcGIS, and then do the analysis and how to create a map. So for those that are not familiar, this is the ArcGIS. This is one of the best softwares for spatial analysis that we have. It's a paid software, so we do need a license. But some universities have agreements to give those licenses to the students and the faculty. Duke is one of them. So we can, if you're a student, you can have a license of ArcGIS. If not, they do have some student accounts and some business accounts that are lower. The prices are lower than the standard prices. So to explain to you the data analysis today, I'm going to be using some road traffic accident data from Brazil, and we're going to be evaluating data before and after the driving draw law in Brazil. So the driving draw law is a law that was established in 2008 that forbids driving after taking any milligram of alcohol. And if you're driving and you get a catch, the breathalyzer will give a positive with any amount of alcohol, and you're going to be charged. So this law was to prevent big road traffic injuries. And since we have mortality data available from Brazil, we're going to see if there's a difference on the spatial time distribution of those deaths. So I'm going to be using a data from my state, Paraná, which is a little bit easier to work. So just in this introduction, we're going to be using just one state of Brazil. Feel free to ask questions, to raise your hand, to say whatever you want to say, okay? So the first thing that we want to do here is to import the shapefile. So for those that do not do spatial analysis, a shapefile is a type of file that allows geographic information on it. So a shapefile will contain information about, is a polygon, most of the cases, but it can also be a point shapefile or a line shapefile that has length information, that has geometry information. And you can download these shapefiles usually from governments, websites, agencies. The United States have, the Brazilian have, and it's very easily, usually, to have those. Of course, those more specialized data, such as rivers or such as points of specific places can be a little more difficult for you to find, but just the geographic territory of that such country or such state or city is usually easy to find. So for the Brazilian one, we usually go to the website of the Brazilian Institute of Geography and Statistics. And they have a lot of information that you can download. The same thing goes for every single government agency that works with geography and statistics. I know that North Carolina has one. I know the United States has one. The CDC has some information on it. So it's very easy to find. And if you just type shapefile North Carolina, usually you do have some government websites informations for you to download it. So it's usually that easy. You can have CSV file, a shapefile. So shapefile is not the only one. It's not the only format that we do for spatial analysis, but is the most useful one. So I already have downloaded the information, and I'm going to add it to my project. So this is a new project. I'm beginning with just a map, and you can see here there's word topographic map and word hue shade. So the topographic map is the one with the colors that works with the topography. And then the hue shade give us a little bit of some hills and some of the, I don't know the word, relevo. What?
Topography.
The topography, yeah. So usually I don't like to work with hue shade, it gets me confused. I just work with topographic map. So to add the shapefile, we go in map, add data. If you click here in add data, you will see a lot of different data that you can add. But you can also just click here on the plus sign and you open the folders that you have, and then you can just select the folder where your data is. So I'm gonna go with my data here. And I have a data called PR Municipios 2020. This is the municipalities of the Paraná state for the year 2020. So here I have the information for a shapefile. So if you click here with the right button of your mouse and go to attribute table, it will open the table that is linked to the shapefile. So you can see here, there's an order number, like an ID number. The shape, what type of shape it is. So this is a polygon because we have defined locations. So each city has a defined location. We can have lines, we can have points, we can have other types of shapes. We have a unique municipality ID. We have the name of that municipality. We have the state. We have the area. We have the code, another code that is a shortened version. And we have the same code twice. Why is that? If you look at here, this one is aligned to the left side, and this one is aligned to the right side. Those that are aligned to the left side are characters or strings. If you see it, that is aligned to the right side because it's a number. It's considered to be a number type of variable. So this is a text variable and this is a number variable. So it's the same thing, but two different types of variables. And sometimes it's useful to have both of them because when you're doing some joins, only the text will work or only the number will work, depending on type of join that you're doing. I see that Sivana is writing here that it's important that you know at what scale you're going to work, because if information does not always have the scale of work that I need, especially to work in small areas. Perfect. So it's important to know the scale that you're working with. You can see the scale right here. So I'm going to close this very quickly to give you a perspective of where we're working with. So this is United States. This is where North Carolina will be in the map, right here. And we're gonna go with Paraná State. That is right here in Brazil. So you can see the perspective here of where we're gonna to work. You can see here also the coordinates of it. So you have the X and Y coordinates. So this is 51 west, 27 south. Of course, we do have a lot of other formats. So this is decimal degrees, one of the most useful ones. And then we also have UTM, UTM. There's also a very useful format, especially if you're projecting some spatial data. Okay, so this is a shapefile. This is where we're gonna go with distributing our data. So now I'm gonna go and add the actual data for the deaths on road traffic accidents. And for that, I'm gonna go with this table. So you can see here is a CSV file. It's called Table Giovanna. So it's from someone that I did this analysis previously. And if you do the same thing, click with the right button and go to open, you can see there is a lot of information here. So this is a information on what we're going to work with. So you can see that we also have a field number. So it's just a ordered number. We do have the same code for the municipality, the city name. Here we have the population, the estimated population before the dry law, after the dry law. We also have it divided into sex, male, female. We have it in age groups. So child, adults, and elderly. And here we have the road traffic accidents, deaths. So the overall, before the dry law, after the dry law, before male, female, it's everything very separate. And we already have the prevalence rate. So the overall prevalence rate before the dry law, after the dry law, for every single type of it. So we're not gonna go with all of this. We're just gonna focus on before, after, and then we're gonna do some comparison. Okay, so this is the data that we're working on, and you can see is a CSV file. And one thing that is usually gets the work easily when you're working with CSV files here in ArcGIS is that sometimes it's not gonna be able to join with the spatial data, especially if you're working on CSVs that are, because we have a lot of types of CSVs. You can use spaces, you can use commas, you can use point commas, dot commas, and it's a little bit different on how the ArcGIS interprets this. So one thing that eases the job for us is to export table. So export table is a function here that you can locate on geoprocessing on the right side here. If that is not showing, you can always come on analysis, tools, and it's gonna open the geoprocessing. So, and then you're just gonna type export table. The export table is like a conversion tool. So it's gonna give you a new table that is more aligned to the format that we have on ArcGIS. So I'm gonna go and put my CSV file here in input table, and it already gives you a name. So TBL Giovanna export table. And if you put the mouse on it, the cursor on it, it already gives you the file director. You can also filter if you want. So I just want this information. You can do this here. You can change some fields and you can sort the fields. I'm not going to change anything on this. So I'm just going to go and run. And it's very quickly depending on the size of the table. So here I already completed. It gives me the messages if everything was fine. And now I have here those two tables. And one thing that I know it's easier for us to see the differences here, it's see here the field. I cannot add and calculate when I'm using a CSV file. But if I go the same thing here in the export table, I can add and calculate. So if I don't have this calculated already, the prevalence reaches like I have here, I don't need to recalculate it. So to do that, the SV format is not going to be useful because it doesn't allow me to do this. So I need to export first and then calculate it. So since I already have it calculated, I'm not going to actually calculate it, but I'm going to show you how to do this. And ArcGIS uses Python format of scripts. So it gives you here the input table. You can create a field name, so a new variable, or you can already choose a existing one. So you can just override. You can also have a field type, if it's going to be a text, if it's going to be a float, a double, short, long, date, blob, raster, time only, date only, timestamp. The expression type, so you can also use Python, VBS script. Python, it's probably the most friendly for us. It gives us the fields and it gives us some helpers here. So some functions that are easily to follow that maybe someone that is not used to Python can use it. But we also can just type something like, okay, I want to do the number of accidents divided by the population and multiply it by 100,000. It gives you this possibility. So it's going to give you what is going to happen. And then you just apply, okay, and it's going to create this new variable. I'm not going to do this, but because I already have the data here. So after that, what you want to do is to join those two things. We do that by clicking here in join and relates. And then we're going to add join. So it gives you the input table and the join table. The input table must be the shapefile. And you're going to go with the code for the municipality and needs to be a unique code. Needs to be a unique code. Because if it's not, then it's not going to validate, and then that's not going to be a match. And then we can see this very easily. I'm going to use this one, code municipality. And I'm going to go with code IBGE here. So this one right here has 7 characters, and this one have 6. So they're not going to be a match. I don't think I'm going to be able to show you. But this one has 7 characters. And the one that we want is only 6. So if I use this, it's not going to be a match. How will I know this? I click this invalidate join. It's going to validate it. And it's going to give me this warning, join had no matches. And it's going to say the input table has 399 observations, and the join table has also 399 records, but it has no matches because I'm using the wrong one. So this is just a heads up because I do struggle with this sometimes, especially when I'm trying to get this information here when it's text and numbers. So if I do validate now using the código variable, a one-to-one join has matched 399. So after I validated, I can simply click OK. And then I do have everything of my table here on my shape file. In an ideal workflow, you will want to export this as a new feature. So we won't have this shape here erased. So this shape here is the standard for all municipalities of the state. We don't want to lose it, right? So we don't want to erase it by saving, overriding it with new information. So we do want to export features as a shape file. But I'm not going to do this because I already have this one for doing this. One thing here that allows us to see it is the distribution of the map. So we're going to go with the symbology. The Symbology tab here. So Symbology allows us to create choropleth maps. And we can use single symbol, unique values, graduate colors, bivariate colors, which is very useful for us, unclassed colors, graduate symbols, proportional symbols, dot density charts. So ArcGIS allows us to do a lot of symbols. We're going to go with graduate colors. And if you see here, it already gives me some graduate here. So it's using the field of area in kilometers squared. Yeah. So wherever it opens here, the area is going to give me the dark colors being the largest areas. So I don't want areas, I want the prevalence rate. So I'm going to choose the field of the prevalence rate for the whole time set. And you can see here, it gives us a normalization function if you want, the method of breaks, how many classes, and the color scheme. And also gives us here the colors, the upper value, and the label. So the method that it's using is the natural breaks, the Jenks natural breaks. It's probably the most useful ones when we do want to, when we're working with a lot of zeros, because the most used ones is the quantiles. The quantiles distributes the exact number of municipalities for each class. So it's quantiles. But when we do have a lot of zeros in most of our data sets, it will give us 2 or 3 classes with just zeros, which is not useful. If you go to geographers, they're going to say that 0 actually needs to be in a separate label just for zeros. Sometimes it's not useful for us to have zeros separate here. So it depends on which data you're working with and what type of outcome you're having. I'm going to stick with natural break. and I'm gonna increase a little bit. So I'm gonna put 10 here. And one thing that I like to do personally, I don't usually go for these screaming colors, especially for something like this. I usually like some more soft, like this one, green and blue. Of course, that you're working with a lot of blue, you're gonna get confused with the seas and the topographic map, but it's easier to see. It's also when you're working with spatial analysis, you do need to have the visual and making it important to not create something that it's aggressive to the eyes. If you don't want to work with green and blue, the option that I would suggest is purple. It's very easy, it's very soft, and it gives us the information that we want. And something that I like to do personally is that I like to apply this color scheme for fill and outline. So it kind of erases the city limits, the city borders here. Depending on what you're working with, it's easier to see the colors, the more lighter colors. So you can see it where it's exactly gone, especially in the smallest cities. But again, this is very personal. The colors and the amount of classes using fill or not, the outline or not, is something that you're gonna get used to it, and depending on what type of data. Okay, so now I'm gonna just change here for, this is the previous, before the dry law. So this is the same thing that I already did for before the dry law. Before the dry law, I have this distribution. After the dry law, let's see how it changes. And to do that, I'm gonna create another map. So I'm just gonna copy and paste here, and I'm gonna change from antes to depois, which is before and after. And you can see here that change it. So we work with, how do you call this again? Layers. So we're working with layers, right? So this is the layer for after. If I click here, it will give me the before. So you can see the difference here on how the dark colors change it a little bit. So before the dry law, it was mostly here close to the beach and here closest to the south west. Now it's a little bit more in the north and some here still. Of course, that the parameter here is a little bit different. It's something that you need to be careful. So we do have different scales for before and after. In the ideal world, you will want to use this in the same scale. So you want these breaks to be the same for before and after, especially if you're working with a comparison. So if you're going to work with women and men and women, or if you're going to choose before and after some point, some time, spatial time analysis or something like that. Okay, so now we're gonna do is the hotspot analysis. To do the hotspot analysis, we're gonna go back to the geoprocessing tab. We're gonna go to hotspot. Hotspot analysis, which is called Getis Ord Gi star. So this is one type of spatial statistics. And what it does is it gives us information on significance, looking not only that single municipality, but also the neighbors. So it's going to give us information if that municipality is important and how it's going to create a pattern within its neighbors. So what we want here is impute future class, which is our shapefile. So you see here we have the standard, and then that one, because we have two different ones. So I'm gonna stick with this one. It gives us an output feature class because it's gonna create a hotspot layer. And the field here that I want to use is the prevalence rate before. So I can choose the conceptualization of spatial relationships. I can choose fixed distance band, inverse distance, zone of difference, key nearest neighbors, which the one that is more useful is contiguity edge corners. That's what we call a clean, smooth spatial relationship. So it's gonna create like a mean between that municipality and its neighbors, and it's going to consider neighbors every single municipality that touches the minimum part of the border of that municipality. One thing that is really important here, and it's going to be more requested now from the journals, is the false discovery rates correction. And I'm going to run this without the phase discovery and then run after it with the phase discovery. This one is a correction for the p-value, because usually we're going to go with 0.05, but since we have a spatial relationship here, it's useful to use a false discovery rate. So it's going to give us a lower p-value, indicating the real significance. So this one, I'm going to just run it. So it gave us the patterns. So if you see here, it gave us cold spots, hot spots. So the blue and green ones are the cold spots with 90% of confidence, 95 and 99%, 99% of confidence. The same goes for the hot spots. So 90%, 95%, and 99%. So we know that before the dry law, this is the area where you had the most road traffic accidents related deaths here in the state. We also have some here, and these are where it was lower than the average. I'm gonna run this with the discovery rate correction. So here it gave us none, because probably the phase discovery correction was too low, which sometimes happens. If it's too low, then it's probably not going to be significant. Then we do a run with the standard one, and then we say this is a limitation. Probably because we're using a very specific time period. We do need to assess this from time to time to make sure that we need to use the data correctly. So this is the patterns for before the dry law. And now I'm gonna run after the dry law. I'm gonna go with the same things. I'm just changing it for after the dry law. And you can see how it changed it. So now this whole area is now a cold spot. And a context here. This is where we have our capital. So this one here, I think is Curitiba. One of those is Curitiba. I'm not sure which one now. But this is our capital, or meaning that it's the biggest city, the largest city. So it decreased in the largest area and in the beach area, meaning that it's where probably you had most people having those accidents, especially where they're gonna have higher police actions here, because it's the biggest city, is where people go to enjoy themselves, and then it's probably where they're gonna have the biggest police tasks here. But you can see that it shifted a little bit. It was the whole area of the Southwest, and then it's now just a little bit up here. And those are cities where you have a small number of people, and also where you have more agriculture forest fields here. So you can see that how they change it. But one thing that ArcGIS allows you to do is not just being comparing like this. After you did that, you can also do hotspot analysis comparison. So you're gonna be comparing two hotspots. So result 1 should be before, result 2 should be after. Gonna give us the same things. It's gonna give us this information here that sometimes it should be changed, sometimes not. You can put it in a standard or change how it's best for your data or what you're doing. One thing that I do like to change is the number of permutations. I do like to use 99.9. Then I run it. And it's gonna give us a lot of information here. The one that I'm interested in is the significance level combinations. So this one allows us to see if it was cold to hot, not significant to hot, hot to hot, hot to non-significant, not significant to not significant, cold to not significant, cold to cold, not significant to cold, and hot to cold. So you can see here that the most part of it was hot to non-significant, cold to non-significant, non-significant to hot, non-significant to cold. But you do have some cold to cold, meaning that it was cold before and it's cold after, hot to hot, meaning that was hot before and hot after. So this is very useful for when we're trying to do some spatial analysis that has a very clear time point, such as dry law or before and after implementation of a health policy. So we could use this to compare delivery modes before and after a major change in how the maternal and child care is provided, or before and after some law, some policy. Of course, that if you're trying to see how it's in every single timestamp, it's also useful to use other type of analysis like space-time cube. But if you're trying to see a combination of before and after an intervention, this is probably the most useful one, because you can then see how it changed. And then you can run this with some type of regression or some type of geographic information or sociodemographic information to see if give you some more hypotheses on what's going on. Also, if you want to do a distribution, I'm gonna do this very quickly. I'm gonna go and create just another one. I'm gonna go back to the Symbology, and one thing that is very useful here on ArcGIS is that you can actually create bivariate colors maps. So allows you to give information on two variables, and it creates a bivariable map. And I can do this putting the information before and then after. So I have the distribution and not only the statistics. So this is very useful for when you're trying to do this, or when you want to compare it with other sociodemographic data, because it gives you this. So before it's in pink, after is in blue. If it's very pink, then it's only high before. If it's very blue, then it's only high after. If it's purple, it's high before and after. And if it's a very, very light purple, it's low before and after. So this is a function that is very useful for when you try to compare those two timestamps. It gives you some more background and information on how to compare those things. So this is what I wanted to present for you today. It should be very simple, very direct on point, just to give you a concept of spatial analysis, some hotspots, what is it useful for. Of course, you don't need to use for a different time stamps. You can use just for one cumulative period, or you can use for one single time. It's up to which data you have, what it's useful for. And one thing that is very useful for data analysis, spatial analysis, is that it gives you room for creativity. So you can choose colors, you can choose different types of data, you can choose different types of distributions, you can choose whatever fits best for what you're trying to accomplish. Of course, we're not going to modulate the data to give us a wrong scenario, but it gives you some room for creativity on how you should show this data. And I'm gonna just go for it and just show you how the project was after I finish it. So I'm opening the project, the original project. And these were the maps that I created and how I presented it. So this is before and this is after. So I created a new, a figure where I have what is reading and then some, the prevalence here, the legends, the scale, a north sign here, north arrow. And then I did as well as analysis, a comparative before and after. So it gives you this, and this is how you should present a map. Of course, there's other types, but this is how the main author wanted me to present. This is what I wanted to show you. I hope it was useful for you.
It is very good, Nathan. Yes, this is one of the ways we can do this session. So Nathan, he was not talking about the theory behind this analysis. He was giving a tutorial on how to. I'm sure there's a lot of conversation. I'm sure Silvana would have several top suggestions on handling data here or there, discussions about the actual topic, but this is great. This is a great tutorial that we can show people again. Loved it. That's very good. Thank you very much. There's some questions in chat. In particular, Ashley asked how people learned GIS, and maybe that's something we can have a session one day just talking about how people go about learning different methods. The point here at Duke, they always have some very good introductory courses at the beginning of the semester with the visualization lab. Those are very nice to take. But yeah, overall, this is kind of the idea. It's to show different types of methods and applications. So, Nathan, can you pull up the schedule? Okay, so I'll just pull up my screen. All right, so for next week, we don't have anybody listed, neither for the next 2 weeks. So please, people, let's get your lists. As you've seen, you don't have to be an expert on the field. You can come in and show an analysis you've already done, guide us through the codes, help us build tutorials. Please mark your name. If we don't have presenters, we don't have a meeting. And as I said before, I would really like that everybody that is visiting us is here with us or is part of the group somehow to engage. This is how we offer back to the group, and this is how we get back from the group. So please list your name. It doesn't have to be anything too specific, too clear. It can be just something you're studying and bring for discussion, a paper you found interesting or anything like that. Okay? I hope to see this filled in by the end of this week for everyone. Okay. In order for us not to have any thoughts open for next week, is anybody volunteering to present next week? And it cannot be Nathan and João Vitor, please.
Hello, Joe.
Hello.
I can volunteer to do a